What would happen if you stepped onto Mercury, or if you plunged into the crushing depths of Jupiter? How fast could you die on each planet in our solar system? The truth is more terrifying than most of us can imagine. Every planet, from the blistering heat of Venus to the icy winds of Neptune, presents a unique and deadly challenge to the human body. Some would kill you almost instantly. Others would slowly, painfully claim your life in ways that are almost unimaginable. On Mercury, you wouldn't last a minute. Your body would be exposed to temperatures hotter than an oven one moment, freezing cold the next. Without air to breathe, you'd lose consciousness in seconds, while your body's fluids begin to boil under the low pressure. Venus, meanwhile, is a planet of crushing pressure and suffocating heat. The atmosphere is mostly carbon dioxide, thick enough to squash a human like a grape, and temperatures soar high enough to melt lead. There's no chance of survival here. Mars might seem calmer, but the thin atmosphere is mostly carbon dioxide. You'd pass out from oxygen deprivation in less than 15 seconds, and the cold would freeze you faster than any winter on Earth. And then there are the gas giants. Jupiter and Saturn don't even have solid surfaces. Fall in, and you would suffocate almost instantly, then be crushed by unimaginable pressures as you sink deeper into the thick atmosphere. Uranus and Neptune, suffocation, freezing cold, and violent winds that could rip a human apart. By the end of this journey, you'll know which planets are instant death traps and which ones are just slightly slower killers. Strap in, this is what it's really like to die on every planet in the solar system. Before we dive into what it's like to die on every planet, we need to understand the stage these deaths would take place on. Our solar system's planets fall into two broad categories: terrestrial planets, rocky worlds like Mercury, Venus, Earth, and Mars, and giant planets, huge worlds composed mostly of gases and ices with no solid surface at all. Terrestrial planets have a defined surface you could, in theory, walk on, while gas and ice giants are more like vast, crushing atmospheres you'd sink into forever. Human survival anywhere depends on three main factors: atmosphere, pressure, and temperature. On Earth, our atmosphere gives us breathable air at a pressure that keeps our bodily fluids stable and our temperature regulated. In most other places in the solar system, one or more of those conditions is deadly. A common misconception is that a human would explode in space or on a low-pressure world without warning. In reality, bodies don't explosively burst, they swell, suffocate from lack of oxygen, and fluids boil because of low pressure, but not in the explosive way Hollywood shows. By the end of this journey, you'll know which planet is the fastest way to die, and which ones might surprise you with how they take your last breath. Mercury, the scorched survivor. Mercury is the closest planet to the Sun, a tiny world of extremes where the environment is literally trying to destroy you the moment you arrive. Unlike Earth, Mercury has almost no atmosphere, just a whisper of particles called an exosphere that cannot support breathing or protect you from temperature swings or solar radiation. This means there's no air to breathe, no pressure to keep your body stable, and no blanket to moderate temperature. On the sunlit side, surface temperatures on Mercury soar to about 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead and roast any unprotected surface. That firestorm heat hits you unfiltered because there's no atmosphere to block or scatter the sun's radiation. But Mercury doesn't stay hot because it spins so slowly and lacks an atmosphere to retain heat. The moment night falls, the temperature plunges to around minus 180 degrees Celsius, 290 degrees Fahrenheit. This is one of the largest temperature swings in the solar system, over 600 degrees Celsius between day and night. So what would happen if you somehow stepped onto this unbearable world? First, within seconds you would suffocate, there's no breathable air, and your lungs would rapidly lose pressure in the vacuum like the exosphere. Next, your bodily fluids, including saliva and moisture in your eyes, would begin to boil as a result of the extremely low pressure. This isn't heat-induced boiling like on a stove, but the physical response of liquids when pressure drops below the point where they can remain liquid at body temperature. Meanwhile, Mercury's thermal extremes start to assault your body. On the day side, the intense heat would scorch your suit and skin, baking you in place. On the night side, without any atmosphere to hold warmth, the temperature would plunge so rapidly that freezing cold would follow almost as fast as the heat left you. In a single Mercurian day-night cycle, which lasts about 176 Earth days, you'd fry and freeze alternately, a chilling and burning rhythm that under no circumstance would allow recovery. There are pockets near the poles where water ice can exist in permanently shadowed craters, but even those frigid safe zones still offer no breathable air or pressure that could save you. On Mercury, the closest world to our Sun, survival isn't just unlikely, it's scientifically impossible for an unprotected human. The planet's lack of atmosphere, terrifying temperature extremes, and direct exposure to solar radiation make death swift and unavoidable. Venus, the pressure cooker. Venus is like nothing else in the solar system. It's often called Earth's evil twin because it's nearly the same size and mass, but that's where the similarities end. Instead of a life-supporting atmosphere, Venus is wrapped in a crushing blanket of mostly carbon dioxide, about 96.5% carbon dioxide, with thick clouds of sulfuric acid that hang overhead like a toxic shroud. At the surface, the atmospheric pressure is about 92 times greater than on Earth, equivalent to being almost a kilometer beneath the ocean here on Earth. This suffocating weight would flatten a human body instantly, with no chance of resistance. Just breathing here isn't an option. The dense carbon dioxide atmosphere traps heat in a runaway greenhouse effect, making Venus hotter than Mercury, even though it's farther from the Sun. Surface temperatures average around 462 degrees Celsius, which is 864 degrees Fahrenheit, hot enough to melt lead. These blistering temperatures and insane pressure don't just make Venus uninhabitable, they make it a planetary pressure cooker where nothing like earthly life could survive for even a fraction of a second. Imagine stepping out of a spacecraft onto the surface. Within a heartbeat, you would be crushed under the atmospheric pressure. Your suit would be squeezed as if you were standing a kilometer below Earth's ocean, far beyond what any human body or suit can withstand. The pressure alone would be enough to collapse your lungs and organs. Then there's the heat so intense that it would cause catastrophic organ failure almost instantly. The blistering temperature would cook you from the outside faster than you could gasp your last breath. And if somehow that wasn't enough, the skies above are filled with sulfuric acid clouds. These aren't gentle rain clouds. Like on Earth, they are corrosive droplets of acid that would eat through metal and flesh alike. You wouldn't reach this point alive, of course, because the overwhelming pressure and heat would have already claimed you. So could you survive 1 second on Venus? The short answer is no, not one, not a fraction of one, not a single heartbeat. Every second exposed to Venus's surface conditions would be fatal. The atmosphere is too thick, the temperature too scorching, the pressure too lethal. Venus doesn't kill you slowly, it annihilates you immediately. But it's this very brutality that makes Venus such an intriguing subject for scientists, trying to understand our own planet's climate extremes and atmospheric behaviors. In short, Venus is not just hot or dangerous, it's one of the most hostile places in the entire solar system. You wouldn't just die here, you would be obliterated by pressure and heat before your body even realized what was happening. Earth, the safe haven. Earth is the only planet in our solar system where humans can survive without specialized protection. Its atmosphere is perfectly balanced, providing breathable oxygen, protective pressure, and temperatures that sustain life. Unlike Mercury's scorching days, Venus's crushing heat, or Mars's freezing deserts, Earth offers a stable environment where our bodies function naturally. Survival here isn't just possible, it's the default. Of course, Earth is not entirely without danger. Extreme environments like Antarctica's icy plains, the boiling heat of deserts, or high-altitude locations with thin air can challenge human survival. Yet, even in these extremes, humans can adapt with clothing, shelter, and technology. Compared to the rest of the solar system, these dangers are minor inconveniences rather than instant death. Humans are uniquely suited for life on Earth. Our physiology, lungs, circulatory system, and ability to regulate body temperature evolved precisely for this planet. No other world offers the combination of oxygen, pressure, and temperature that makes us inherently capable of survival. In short, Earth is not just a safe haven, it's the only planetary home in our solar system where life as we know it can thrive. Every other world we'll explore is a death trap waiting for the unprepared. Mars, the freezing desert. Mars is cold beyond anything most humans have ever felt. Your exposed body would rapidly lose heat, leading to hypothermia once unconscious. So here's the chilling question. Could you survive a moment on Mars without any protection? The scientific answer is no. Not a breath, not a minute. You wouldn't make it long enough to feel the cold bite deep into your bones. The lack of oxygen would erase consciousness first, the low pressure would turn your fluids to vapor, and the freezing temperatures would finish the job. Mars may be one of the most explored worlds in our solar system, but its surface is utterly unforgiving without life support systems. In order to survive there, you'd need the equivalent of a small Earth inside a suit of oxygen, pressure, and temperature control to keep every one of your cells alive in a place that, on its own, would kill you in minutes. Jupiter and Saturn, gas giants. Jupiter and Saturn are the giants of our solar system, colossal worlds made mostly of hydrogen and helium, with no solid ground to stand on or breath to sustain life. If you thought Mercury's furnace or Venus's pressure cooker were brutal, nothing compares to the crushing, suffocating death that awaits in the depths of these gas giants. Their very nature, vast, endless atmospheres, means there's no surface to land on. Instead, you would fall into an ocean of gas that only gets more deadly the deeper you go. Jupiter, the largest planet in our solar system, is essentially a massive ball of gas. Its upper layers are swirling clouds of hydrogen and helium, with storms and winds that dwarf anything on Earth. As you descend below the cloud tops, the atmosphere becomes denser and the pressure begins to rise dramatically. There's no solid crust or rock layer, it's gas all the way down until the pressure and temperature compress the gas into liquid and eventually a sea of liquid metallic hydrogen deep inside. Imagine stepping off a platform into that invisible abyss. Right away, there's no breathable air. You would suffocate the moment your lungs attempted to draw in the thick, hydrogen-rich atmosphere. Humans need oxygen to live, and Jupiter's composition offers none. Even if you somehow had a continuous supply of oxygen to breathe, the pressure would quickly become your enemy. Jupiter's gravity squeezes the atmosphere so intensely that pressure deep inside is millions of times greater than Earth's, enough to crush any spacecraft or human body without hesitation, and it gets hotter as you fall. The deeper you go, the more the immense pressure drives temperatures upward. In the lower layers of Jupiter's atmosphere and interior, temperatures soar to levels hotter than the surface of the Sun. This extreme heat would cook you from the outside in long before you reached any kind of dense core. There's no safe zone, no plateau where you could pause your descent. It's a one-way trip into an ever more hostile world. Uranus and Neptune, ice giants. Out beyond Saturn lie two of the most mysterious and frigid worlds in our solar system, Uranus and Neptune. These planets are called ice giants, not because they're made of ice in the way Earth's poles have ice caps, but because they're dominated by volatile compounds like water, ammonia, and methane in deep, dense layers beneath an atmosphere primarily of hydrogen and helium. Unlike terrestrial worlds, these planets lack solid ground, and their icy, gas-filled domains are utterly hostile to human life. Neptune, Uranus's frigid neighbor and perhaps the wildest planet in the outer solar system. Neptune's atmosphere is also dominated by hydrogen, helium, and methane, but this distant world has earned a reputation as the windiest planet known, with winds that can exceed 2,000 kilometers per hour, more than 1,200 miles per hour, faster than the strongest storms on Earth by a wide margin. Those supersonic winds whip methane clouds around the deep blue planet with unbelievable force. Imagine those winds slicing across your body after you've already lost consciousness from lack of oxygen. You'd never see it coming until the freezing winds hit. Even if you were somehow equipped with breathing gear, the storm force winds and rapidly dropping temperatures would tear at your suit and pull your body apart before long. And deeper into Neptune's atmosphere, crushing pressures and rising heat would finish the job, a relentlessly hostile mix that no human technology could withstand without total protection. Uranus and Neptune might seem quiet and distant in telescope images, but their atmospheric forces and bone-chilling cold make them two of the deadliest destinations in the solar system. On every front, no air, extreme cold, crushing pressure, and violent winds, they offer no refuge for a human. In these ice giants, death isn't only fast, it's inevitable. Fun what-if scenarios. Now that we've seen how deadly every planet outside Earth can be, let's take a moment to imagine some what-if scenarios, the fun side of thinking about extreme survival in space. Could we ever terraform Mars to make it habitable? Scientists have speculated about warming the planet, thickening its atmosphere, and introducing oxygen. While these ideas are intriguing, even the most optimistic scenarios would still leave Mars dangerously cold, and the surface pressure would remain far below what humans naturally need to survive. In other words, you might get a few minutes of life, but without technology and protective habitats, you're still in a frozen, suffocating desert. Could we float in Jupiter's upper atmosphere instead of falling endlessly toward crushing pressures? Theoretically, a specially designed floating station could hover in a layer where pressure and temperature are tolerable. But in reality, the planet's extreme winds, storms, and radiation make it nearly impossible for humans to survive without fully enclosed life support systems. Even if you had oxygen, gravity, and crushing forces would make it a one-way trip if you drifted too far downward. So, which planet could you survive the longest? If we're talking outside of protective gear, Earth obviously wins, but hypothetically, Mars offers the longest last gasp, where hypoxia and freezing temperatures act more slowly than the instant deaths of Venus or the gas giants. Mercury's searing days and frozen nights give a brief, extreme oscillation, while Neptune's hurricane-force winds would rip through anything unprotected. Comparing the scenarios becomes almost like a twisted game. Mercury fry versus Neptune freeze, Venus crush versus Jupiter squeeze. Each world has its own lethal signature, and imagining surviving them is both terrifying and fascinating. Even though we cannot survive on these planets naturally, thinking through these scenarios teaches us about Earth's unique life-supporting balance and how extreme environmental conditions shape planetary science. It also sparks curiosity. Could future technology allow humans to live, float, or even thrive for short periods on these otherwise uninhabitable worlds? These what-if exercises are more than just fun, they're a reminder of how fragile life is and how incredible Earth really is. As we come to the end of this cosmic journey, one thing is clear: humans would die on every planet in our solar system except Earth. From Mercury's scorching days and freezing nights, to Venus's crushing heat, to the icy winds of Neptune, each world presents a unique, deadly challenge that makes survival impossible without protection. Next time you look at the stars, remember this: some places in space are not just inhospitable, they are instant death traps. The very planets we admire in telescope images are far more dangerous than we can imagine. If this journey through the solar system fascinated or shocked you, don't forget to like, comment, and subscribe for more mind-blowing space content. Dive into our other videos to explore black holes, exoplanets, and the limits of human survival beyond Earth. The universe is beautiful, mysterious, and terrifying, and there's so much more to discover.